Welcome to all of you. Today we will learn the implementation of simple linear regression by using Python programming.
Let us learn how to implement simple linear regression model over the dataset. So here we must understand regression means the measure of relation between variables or piece of data. The basic objective behind the simple linear regression is to establish relationship between two variables, and another objective of simple linear regression is to predict new observation. So before I will dive into this machine learning modeling, I want to show you about this placement.csv file. So this is my data which I am going to be used for implementing this simple linear regression model. Now here you may see there are two features we are having. One is CGPA, another one is a package. The dimension of this data file is there are around 200 rows and 2 columns. Now this data file is already available over the kaggle.com. From there I have faced this, I took this data. Now to implement this regression, these are the essential libraries which we have to import. Now already we have discussed about the steps which are essentially we have to perform for developing the machine learning model. So we have to begin with the data pre-processing, which basically consists this operations. So here basically we are having a 2 column, and I am knowing that there is nothing kind of missing value or duplicate values are present over there. So this pre-processing and feature selection is not required at this time. So basically to understand the relationship between independent and dependent variable, we have to perform the EDA so that we may understand the relationship between independent and dependent variable, because there is a certain assumptions which need to be satisfied if you want to apply simple linear regression model over the dataset. So that part we can check by performing this EDA operation. After doing this, subsequently these are the steps we will perform over the dataset. So already we have seen this placement.csv file. Now to import this file over the data frame, over this our environment, we have to use this pd.read_csv method. So by this way, we will create our data frame df. Now to check the shape of the data frame, there is a method called shape. So this will tell you the dimension of the data frame. So here it is a 200 by 2. Means there are 200 rows and 2 columns we are having. Now to have a glance about the how data will look like, I'm this time using the sample method. So it will show you the 5 random rows corresponding to both the columns. So here this value we will get. So from here we may understand that how these values are related with each other. Now to visualize the relationship, the best idea is we should go with the plotting. So we are having a method called this plt.scatter. So this will basically use for doing a scatter plot. So a scatter plot basically be used to check the relationship between x and y variable. So here in our case, x is nothing but the CGPA, and over the y-axis we are having a package. So to understand the relationship, we have plot this to value. So once we execute this command, this is the outcome which we are getting. Now we can say that two variables are in linear relationship when their value can be represented using a straight line. That means data point lies on the straight line. So here one thing important, we can observe from this picture that CGPA and package is having a positive correlation. What does it mean? It means that if you increase the value of CGPA, in the same way the package is also going to be increased. With respect to CGPA, package is also increasing. It simply means they are having a positive correlation with each other, which shows that in this data set, we can apply a simple linear regression. With this understanding, we can move further and we can apply the subsequent step. Since in our case, only one feature, one independent feature we are having and one dependent feature, our target variable we are having. Otherwise, we have to check the relationship among the features as well, because we have to satisfy the assumptions of simple linear regression. So here it is satisfying that part, that clause. That's why we are moving ahead. Now the next step is we have to split the data set into X and Y. So here the first column we are keeping into this capital X, the target value we are keeping into the Y. Now you may see the outcome of this step. Now this is my X value. So here you may see there are 200 rows and one column, that is a CGPA column. Similarly, you can observe the Y value. In Y value again the same 200 rows and one column we are having. So after this step, the next step is we have to split the data. So for that regard, under this model underscore selection module, which is a present in this sklearn package, we have to import this train test split function. Now this train test split function will take this capital X which we have generated and Y as a parameter, and here we have to specify the test size or train size. In this case, I have given the test size is equal to 0.2. It means 20% data I am giving for the test purpose. Remaining 80% of data we are passing for the training purpose. And here random state is equal to 2, which is nothing but it will generate the random sequence. Accordingly, the data will become randomized. So if you see this, already we have learned this thing in our previous discussion. So basically this function, this step is going to be returned 4 value as the outcome. It will give you the X train, X test, Y train, Y test. Now with the image also we may understand the same step. So this was our data. I have identified my X and Y and then I have splitted this. So after splitting this 4 component, we are getting as the outcome. Now with the help of this train X and train Y, these 2 value I will give for the training the model. Once my model has been trained, then I will pass this text X value to this model. This will give me the Y predicted value. Now with the help of Y actual and Y predicted, I will compare, and based on this comparison, I will find out the accuracy score, and which will help us to decide or which will help us to select the best model. With this understanding, let me show you how this train X, train Y, test X and test Y will look like. So this is my X train value. So you may see here there are 160 row out of 200 is kept under the X underscore train. Similarly, under Y train again we are having this 160 row and one column. In X test we are having this 40 observation. Similarly in Y test we are having this 40 observations, right? Now once we are having it, as we have understood in this picture, we have to pass this X train and train X and train Y to the model. Similarly we are using this 2 component and to this modeling purpose. So from sklearn package, under this linear underscore model module, we are having a class called linear regression. So what we are doing, we are making a one object of this class. After making the object, now I can fetch all the methods, all the functions which are available in this class that we can fetch. So what we are doing over here, after making this object, I am fetching this method which is available under this class, that is a fit method. And for this, to this fit method, we are passing our X train and Y train value. So after executing it, basically we are training our model. Now model has been trained after the execution of this statement. Now the next step is we have to pass X test to this model. So let us first see how the X test will look like. So this is my X test data. So there are 40 observations we are having, and this is a corresponding y test value. So this is a y original value, right? So what we will do, we will give this x test value to our model. That model will give us the corresponding y predict value. Now this is my y actual value, and after the experiment we have obtained the y pred value. Now we have to compare this y test and y predict value, right? So that will give you the accuracy of the model. Or in another way we can say that will tell you about the error, right? So with this, what we have done, I have given the original text value, that is the first value I have given to my model. Now this will give me the predicted value. So this is the predicted value. If I will give this x test I log 0 value, so this will give me the corresponding y value. Let me show you that one. So here the x value, the first x value is nothing but 8.58. Corresponding to this 8.58, the actual y value was 4.10, but my model is saying the y value should be 3.89. So you may see the real value is 4.10, but my model is saying it is a 3.89. So there is an error, right? So there is a difference between actual and predicted, right? So this difference is nothing but the error. Now to visualize how our model will look like, because in simple linear regression we just try to find out the best fit line. So that is the main intention behind this SLR. We have to find out the best fit line. So let me show you. This is our data. This is a spread of our data. So this red line is nothing but our model. Now with this image you may understand that number of lines may be passed from this data set. Our intention is to find out the best fit line. What I want to say is we have to find out a line for which the error term is nothing but the error between predicted and actual. For example, this is my red line is representing my predicted value and this is my actual value. The difference between these 2 points is nothing but the error, right? So we have to find out such a line for which this error term should be minimum, right? So that is the entire intuition behind the simple linear regression modeling. Okay, so once we understood about this line, it simply means we have figured out the value of m and b, because it is a straight line. An equation of line can be represented like y is equal to mx plus b. So if you have found this line, it simply means we have figured out the value of m, that is nothing but the coefficient, and b is here nothing but the intercept, right? So if you figure out this one, it simply means we can obtain the value of m and b. So with respect to this model, the value of m would be this one, right? So if you want to find out the intercept as per the model, so this LR is nothing but my model. So LR dot intercept underscore will give you the value of b. So this is the value of b, right? So this both the value we have obtained. It simply means I can express the relationship between dependent and independent variable, right, by finding out the value of m and b. So that can I represent by this way, right? So this y was a dependent variable, this x was the independent variable. So now if you give any x value to this equation, any unseen x value to this equation, because I am having this m value and b value with me, so if I substitute this value of m and b over here, this will tell me about the value of y. So that is the idea. That is how the prediction we use to perform. Similarly, if I want to find out the value of y at the point 9.5, so simply we have to substitute the value over here. It will tell you the value of y, right? Similarly, we can check with the other value. Now we have to understand the intuition, right? How this how we are getting it. Can we implement our own simple regression model, right? Or in other words, how they have designed, because see, as we are knowing that all these models, all these algorithms are already implemented in this sklearn package, right? So can we make our own regression class? That is a question. So before understanding, if you want to learn about it, we must understand the error term. So basically, our error can be expressed in the terms of m and b. It is a function of m and b. Let me show you how the error term, the loss term, is actually look like. So for that regard, I have searched this gradient descent GIF file. So let me show you. This is how actually the relationship between error and m and b are related with each other. Let's say this is my error term which I am representing on this axis. This is the m and this is the b. Now this is the function, this is a function how it will look like. So basically here the intention is we have to find out such m and b for which the error term should be minimum. And for that regard, already we have learned during our intermediate classes that we have to find out the maxima and minima. And for that regard, we have to perform the partial derivative of error terms with respect to m and with respect to b, and we have to make these two values 0. After doing it, we may see, we will obtain the relationship of m and b. For example, let me show you. Once you make this partial derivative is equal to 0, we will obtain the value of m. So this is nothing but my m value and this is nothing but my b value, right? So this m is nothing but the slope and this b is nothing but my intercept, okay? So this value we are getting as a numerator and this value is nothing but we are getting in denominator. So the concern was, can I implement my own class which can perform same like a linear regression class of sklearn package? Then answer is yes. So let us learn that part. How can we make our own LR model? So for that regard, what I did, I have created my own class. So that is here. What I did here, simple LR model I have created. So these are the functions which I have defined. So this is the constructor which will take initially none value. Now this is a fit method. This is for the training purpose, right? So this fit method will take this xtrain and ytrain data. So now see how this m value we are calculating. This m value is nothing but the summation of I is equal to 1 to n xi minus x mean yi minus y mean divided by, in denominator we are having I is equal to 1 to n xi minus x mean ka whole square. The same equation we have to implement for getting the value of m. Same thing I have done over here. So I have divided this two part into numerator and denominator. Let us see. So in numerator what I did, numerator is equal to numerator plus this value xi is nothing but xtrain. So that is a xtrain I minus xtrain mean multiply by ytrain I minus ytrain mean. So you may see here this is ytrain I minus ytrain mean divided by. So this is for the numerator. Similarly for denominator what I did, the same thing we have implemented over there. That is nothing but xi minus x mean ka whole square. So that I have represented like this way. Xtrain minus xtrain mean multiplied by the same component, right? So that will give me the denominator. So if I will put these two things together, numerator divided by denominator, this will return the value of m as per this equation. Now this equation, as we have discussed, has obtained from the partial derivative of error terms with respect to m and b. Okay, so let us come over here. This is my m value. How to obtain the b value? So b value can be obtained by this equation. Y mean minus m x mean. Same thing I did over here. That is a ytrain mean minus m multiplied by xtrain mean. So after that, this fit method will print the value of m and b, right? So that much we have done over here. Now one more function we have defined, that is a predict. So it will take the x test value and it will return the y test as per this equation, y is equal to mx plus c, right? So there is a m, this is a x, and this is a b value. Okay, so this class we have written as per this equation which we have obtained from that equation, from that partial derivative. Now let us give our x10 and y10 value to our own class. So what I did, as the as we have learned earlier, we have to make one object of our class. So this is my class. I have made the object of that, and after that we have to call this method fit, which is available in my class. So you may see here the simple LR is having this fit method. So I am calling this fit method from this class, and here it will take this to value as a input parameter. What it will return? Basically this fit method is returning m and b value. Same thing it will return over here. So you may see here in our case the value of m will be 0.5579 and value of b would be minus 0.8961. Now let us see. Either we are getting same value by using a sklearn package, or the value which we have obtained earlier, that is different from this value. So let us come back over here. Let us check the m value and b value. So the value of m was, yes, it was 0.5579, right, which we have obtained over here. The same value we are getting over here, 0.5579. What was the value of b in sklearn package? Through the sklearn package, this was the b value which we have gained, that is a minus 0.89611. Same value, almost the same value we are getting by creating our own LR model, right? So this is how actually simple linear regression works. Now this value of the value of m and b which we have obtained was the closed form of solution, right? Here basically we have used the direct formula to to calculate the value of m and b, but we are also having one more way, that is known as non-closed form of solution. The example of that is gradient descent. So by using a gradient descent also we can find out the value of m and b. Now concern comes when to use which technique. If I am having a lower dimension, then we should go with this OLS, ordinary least square method. I mean we have to use the closed form of solution. But if you are having a higher dimension, then it is preferable to go with the gradient descent algorithm.
Now let me summarize about this simple linear regression. So the linear regression is a machine learning model that depends on the linear relationship between the variables. The input data is represented by independent variables and the target data is called as dependent variables. So when variable's value increases, if another variable value also increases, then it simply means they are having a positive relationship. But when variable value increases, if another variable value decreases, it simply means they are having a negative relationship. So this simple linear regression model uses the formula y is equal to beta 0 plus beta 1 x plus e, right, where this beta 0 is called the intercept, beta 1 represents the slope of the line, and e is the error term, which is also known as r squared value. Now here we use the function train test split. So this function is used to split the data set into train and test data. It takes either train underscore size or test underscore size, based on which it divides the data set. Thank you.